there is some classification possible for the MTDC system. So, let us see whether we can categorize the MTDC systems into a few types of MTDC system. There are two broad categories. One is series MTDC system and parallel MTDC system. And in parallel again there are two types. One is radial MTDC system, other one is mesh MTDC system. Now, as we have been discussing so far, I will not try to start with a precise definition of what is series, what is parallel. We will try to give an example. Okay. So, example will convey better instead of trying to formulate a definition. So, if I want to know what is series MTDC system, I will start with an example. See, all the figures that were drawn in this class so far are just examples. So, let me take an example. So, I show the AC bus using a short straight line segment, that is the usual symbol used even in the single line diagram, and the schematic diagram of a converter is just a box, rectangle, or it is just a square with a thyristor shown. Okay, I will show it this way. So, I have shown three buses, bus 1, bus 2, bus 3. Bus 1, bus 2, bus 3 are far away. Okay, the distance between 1 and 2 is say a few hundred kilometers, between 2 and 3 it is a few hundred kilometers, between 1 and 3 it is a few hundred kilometers, and at each bus we have a converter. So, on the DC side there are two wires. I show the wire, one wire like this, one wire like this, one wire like this. So, if you look at any converter, there are two wires shown. These are the wires of the DC side. Okay. Now, what I am trying to say is this is an example of a series MTDC system. So, that means the current is same in all the DC current is same in all the three converters. So, if I want one of them to operate as a rectifier, and at least one should operate as rectifier, at least one should operate as inverter. Now, so how do we decide the operation as, suppose we decide some converter to operate as rectifier. So, how do we get that rectifier operation? That is obvious, alpha. Okay. So, if we know that alpha close to 0 is rectifier operation, alpha close to 180 degrees is inverter operation. So, depending on the choice of alpha, we can ensure the we can ensure that we get the required operation. So, if I try to operate a few things as rectifier and a few things as inverter, one of the converters is at least a rectifier, one of the converters is at least an inverter, then the polarity of the voltage across the DC side terminals is dependent on whether it is rectifier operation or inverter operation. Okay, see the polarity, suppose I take the polarity of this with respect to this, the polarity of this with respect to this, polarity of this with respect to this. Suppose I call this VD1, VD2, VD3, and the current is say ID. Okay. Now, at least one of these VD1, VD2, VD3 should be positive, and at least one of these VD1, VD2, VD3 should be negative. If it is positive, it is rectifier. It is negative, means it is inverter. ID is positive. ID is positive. VD1, VD2, VD3 can be positive or negative. If A positive VD1 or VD2 or VD3 means the respective converter is operating as rectifier. Similarly, negative voltage means inverter operation. Okay. So, is this clear? Oh, sorry. So, this is plus, this plus, this minus. Okay. So, this is just an example. Now, let us, I mean, it may not be, straight away obvious why we call this series. Maybe after looking at an example of a parallel MTDC system, then it may become clear why we call this series. Of course, one way is we see that the voltages are the DC voltages. I mean, if I add the DC voltages, I can apply Kirchhoff's voltage law and say that VD1 plus VD2 plus VD3 are adding to 0. Okay. So, these three voltages are in series. So, the DC side terminals are connected in series. So, that is one possible way of defining series MTDC system. In the case of parallel MTDC system, the DC voltage terminals are connected in parallel. Okay. So, again I will take an example. First, I will take the example of a radial system, radial MTDC system. So, radial means it is parallel MTDC system. So, again instead of giving a precise definition, I will first give an example which conveys better. So, again I will show 3 buses, and at each bus there is a converter. So, on the DC side there are 2 wires. I connect the positive terminals of all the converters. Similarly, I connect the negative terminals of all the converters. So, looking at the way I have shown the schematic diagram of the converter, one can see that the converter at bus 2 is shown in a different way compared to the converters at buses 1 and 3. That means, if 1 and 3 are operating as rectifier, then the converter at bus 2 is operating as inverter. Okay. Say the schematic I have shown is like that. Now, this is an example of an MTDC system. Again, please note the distance between 1 and 2 is a few 100 kilometers, distance between 2 and 3 is a few 100 kilometers, and similarly between 1 and 3 is also a few 100 kilometers. So, they are far away. Now, this is a parallel system. So, it may be obvious why it is called parallel, because the DC sides, DC side terminals are connected in parallel, but it may not be obvious why it is called radial. Okay. So, to understand the difference between the two types of parallel MTDC systems, one is radial, another is mesh. I will give an example of mesh. Then we will come back to differentiating radial MTDC system and mesh MTDC system. Suppose I take the mesh MTDC system. So, again this is also an MTDC system which comes under the category of parallel MTDC. So, let us try to look at an example. Suppose I have 4 buses of the AC system, and at each bus I have a converter. So, here I have an example of what is called as a mesh MTDC system, 4 AC buses, 4 converters, at least one of them operating as rectifier, at least one of them operating as inverter. Now, I mean, it should be obvious why it is called parallel. We are connecting in all the DC side terminals in parallel. If you take all the 4 converters, the DC side terminals are connected in parallel. But why it is called mesh? What is the difference between mesh? By looking at the example of this mesh and the example of this radial, what is the difference? Do you see any difference? There is a loop which is formed. Say, the point here is, even if there is loss of one transmission lines, there is a connection between any converter and any other converter. Suppose there are 4 transmission lines here, one transmission line is lost, that means we disconnect. Still, there is a connection established which can be established between any 2 converters. So, that is possible only if you have a mesh connection. Now, this is similar to the AC transmission system. Our AC transmission systems are mesh connections, unlike most of the distribution systems which are radial. See, when it is if you have a radial connection, if you lose one feeder or one transmission line, then you will form islands. But in a mesh system, if you lose one transmission line, then the system is still interconnected. Okay, so that's what is the difference between radial and mesh. Now, mesh will have, of course, some, I mean, it appears as if we have some redundant connections, but that is for the sake of what? See, reliability. But looking at these examples and explanations, we will see whether we can do a comparison of series and parallel systems. Series and parallel MTDC systems. Now, do you see any, say, comparison means maybe one of them has an advantage, other has a disadvantage. Do you see any such possibility? Okay, let me go back to the example. Suppose I have a series connection. I want to change the operation of one of the converters from rectifier to inverter or inverter to rectifier. What I do? I just change the alpha. That is very easy. In the case of series, come to this parallel system. I want to change the operation of one of the converters from rectifier to inverter or inverter to rectifier. What should I do? I have to change the connection also. I have to change the connection. That means I need mechanical switch. There is a mechanical switch required whenever I have parallel MTDC system. That was not required in the case of series. Okay. So, there is one disadvantage of parallel systems, that is high speed. Say, I may actually do the reversal of power flow in the case of series instantaneously, I mean in a fraction of a second, because changing alpha takes only one cycle. In one cycle, alpha was such that the operation is as a rectifier. In the next cycle, I can make it an inverter. Okay. So, high speed power reversal is possible in series system, series MTDC system, by reversal of DC voltage. By reversal of DC voltage polarity. So, when it comes to power reversal in parallel MTDC system, power reversal in parallel system requires mechanical switching. Because you can't just change the polarity of the voltage. In the case of a parallel system, you can't just change the, see, always, see, when you look at the parallel MTD system, suppose this is plus and this is minus, this is plus and this is minus, plus is always connected to plus and minus is always connected to minus. So, you can't just change the polarity of the voltage in the case of parallel. So, that is what we have done even in the case of mesh. So, all the pluses are connected by interconnected, all the minuses are interconnected. Okay. Then any other advantage or disadvantage of one of the systems over the other? Yeah, when it comes to a parallel connection, what is our, our conventional AC system is parallel or parallel or series? AC system, the AC system that we know, they are parallel. Say in series system, through all the equipment the same current flows, but that is not the way it works. In the parallel system, all voltages are same, but not current. Okay. In series system, current is same, voltages is different. So, if I want to change the power, in the case of series, voltage is changed because current is same in all the equipment. In the case of parallel system, voltage is same, but current is changed in order to change the power. Okay. So, one advantage of parallel system is that there is a possibility of staged development, which actually happens in practice. Parallel system has the advantage of possibility of staged development. So, it seems that we prefer parallel, whether it is DC or AC, because of some advantages which will overweigh the disadvantages. See, the only advantage of series is high speed power reversal in the case of MTD systems. We will see that for in all the other aspects, parallel is actually better. So, when it comes to insulation coordination, now, insulation coordination, you may have some idea of insulation coordination, and you will be very knowledgeable if you have studied a high voltage course. Now, which has better insulation coordination, series system or a parallel system? Parallel system. Say, in series system, the insulation at any point is dependent on the current that is flowing. Okay. So, though the current is constant, the voltages are actually variables. See, the voltage which is actually produced by the converter is a variable. So, insulation coordination becomes a problem in series system, is a problem in series system. Okay. Then there is one more advantage of parallel system, that is because if a permanent fault occurs, in a transmission line occurs in a series system, it would lead to complete shutdown, in a series system. Now, why is this happening? See, if you look at the case of this example of series, if there is a complete shutdown, then you can't operate the system because you need each of these components. Suppose you take the wire between converter 1 and 2, wire between 2 and 3 or 3 and 1, all these wires are required for the entire operation of system. Even if one wire is actually not working, the series system does not work. On the other hand, if you take a parallel system, suppose the connection between 2 and 3 is lost, I can still have the connection between 1 and 2 intact. I can still transfer power between 1 and 2. Okay. So, operation of the parallel system is still possible if I remove one of the lines, but that is not the case in the case of series, because the series, I mean, the connection won't get, I mean, the circuit won't be completed without even one wire. If one wire is lost, I mean, the connection is lost and the circuit won't be completed. Okay, so that is one disadvantage of series. So if you try to see the comparison, I mean, it seems the parallel system is better than the series system. Okay. I'll stop here.